Good afternoon, everyone. Welcome to the the second lecture of the week fourth of this course, Principles of Modern CDMA, MIMO, OFDM, Wireless Communication. So I'm Abhishek Thakur, PMRF scholar at Indian Institute of Technology, Hyderabad. So today we are going to discuss the questions based on the week four, like whatever is taught in the NPTEL lecture, and we will discuss some of the concepts, and then we will solve some problem based on that. So before moving to the problem, let's go through the concepts of CDMA. What does CDMA mean, and the basics concepts. Then we will solve few questions, around 10 questions. So we'll start the lecture now, and this video will be recorded and will be uploaded in the YouTube, and the link will be shared on the NPTEL portal, so you can watch it later also. And if you have any difficulty, you can comment on the video, we will reply. So today we are going to discuss code division multiple access. That is CDMA. So it was employed in the second generation cellular standard, and it also forms the basics of advanced third generation cellular standard, such as uh, wideband CDMA, such as wideband CDMA, high speed uplink packet access HSUPA, and HSDPA, high speed downlink packet access, and CDMA 2000 and 1x evaluation data optimized. So it is the basics, it provides the basics of these technology, this cellular standard. So in order to understand the CDMA, it is we need to understand the concepts of multiple access, as CDMA stands for code division multiple access. Like in conventional wireless communication system, what happens, a device is connected particularly through a wired channel, so it is mean to only one device. So whatever is the signal is received only to the one device, such as telephone. However, in the wireless network, mobile phones and other wireless communication devices are required to share the common radio channel. So in wireless network, devices like mobile phones are required to share the common channel. Like you can see in this figure, let's suppose. So this is our base station. So the multiple users are connected to this base station. So multiple access for wireless cellular network is required here. Multiple access for wireless cellular network. Like earlier in 1G and 2G, uh, like time division multiple access was used in the 2G. So in time division multiple access, what happens? The different time slots of duration T are allocated to the user for accessing the wireless channel. User 0, user 1, user 2, user 3. So a time slot T is allocated to the user to access the wireless channel, and the complete bandwidth is allocated to each user. Okay, so this is known as time division multiple access. So in time division multiple access, what happens? Like different time slots T is allocated to each user for accessing the wireless channel. So user 1, user 2, user 3 are allocated with time slots T and the complete bandwidth to access the wireless channel. So this is known as time division multiple access. Also stands for TDMA. So this is the standards for the 2G cellular communication. Now next is the frequency division multiple access. So what is the problem with time division multiple access? So the problem is like no two user can access the channel at a same time. So for this frequency division multiple access is there. In this what happen? Each user is allocated some amount of bandwidth B. So each user is allocated with bandwidth B, and they can access the channel simultaneously. So different users are allotted different frequency bands, and thus the users are multiplexed in the frequency domain, and they access the radio channel in their respective frequency bands of bandwidth B. So this is known as frequency division multiple access. Now coming in frequency division multiple access, the problem was that the one user cannot access the complete bandwidth of a channel. So for these issues, CDMA came. So we will now see the basics of the CDMA mechanism. So it is a multiple access technology based on the code division. So it is a multiple access technology based on code division. So different users are multiplexed using different codes. So we will see with example. In CDMA, different users are multiplexed with different codes. So let's suppose A0 denotes the symbol of the user 0 and A1 denotes the transmit symbol corresponding to user 1. So for user 0, A0 is the denoted symbol. For user 1, A1 is the denoted symbol. Okay? And let the code C0 of user 1 user 0 is given as C0 is given as 1 comma 1 comma 1 comma 1. The above code, like the length is n. So length n is equal to 4 here. So it can be called as 4 chips code. So each element of the code is termed as a chip. The transmitted signal x naught of the user 0 is then given by multiplying with the code C naught. So x naught is equal to A naught into C naught. So we will get A naught comma A naught comma A naught comma A naught. Now the symbol A naught of the user 0 is multiplied by the code C naught to yield 4 chips. Okay. Similarly, now let's take C1 of user 1 is given as 1 comma minus 1 comma minus 1 comma 1. So x1 is equal to A1 comma C1. So this will be given as A1 comma minus A1 comma minus A1 comma A1. Let me connect with the better Wi-Fi. Just give me a minute. My else are corresponding to user 0 and user 1. So now it is summed to yield the net signal x. So x is equal to x naught plus x1. So this is the net signal. So x is equal to a naught plus a1, comma a naught minus a1, comma a naught minus a1, comma a naught plus a1. Now this summed signal is then transmitted via downlink channel, from which each of the user like 0 1 detect their own signal. So this is done as follows: like user 1 correlates the received signal x with its code c naught. So that is like basically it multiplies each chip of the received signal x with corresponding chip of the code c naught and sums across the chip as follows. So what will user 0 will do? It will multiply the received signal x with its code. So it will be like a naught plus a1, a naught minus a1, a naught minus a1, and a naught plus 1 a1. So this received signal, it will multiply with its code. So the code of user 0 is 1111. So finally it will get a naught plus a1, a naught minus a1, a naught minus a1 plus a naught plus a1. Now it will sum it. So the user 0 will receive 4 a naught. Okay. So which is proportional to the transmitted symbol a naught. So this is proportional to the transmitted symbol a naught. So this symbol was transmitted to the user 0. Okay. Similarly, now users 2, sorry, user 1 will receive the signal in this way: a naught plus a1, a naught minus a1, a naught minus a1, a naught plus a1. So it will multiply with its code and sum it. So it will again become 4 into a1. So above, a naught is the transmitted symbol for UE0. So now this is the transmitted symbol for UE1. So both the user 0 and user 1 received their signal which was transmitted for them. So the multiple like code division multiple access is summarized as multiplying or modulation the symbols of different user with its corresponding assigned unique code, and then combining or adding the code modulated signal of all the user to form the composite signal, and then finally correlation of the composite received signal x at each user with corresponding code, and then they received back the symbol transmitted to them. Now we will see some fundamentals of CDMA codes. we'll go through the concept up to the question 1, and then we will solving all the questions. Now, fundamentals of CDMA codes. So like the previous example what we have seen, so that recovers the signals of the user 0 and 1. So now we will compute the correlation of the user code C0 and C1. Let's compute correlation R01 of the user code C0, C1. So this will give summation of C0 k, C1 k, and value of k is from 0 to 3. So when we do this, we will get 1 into 1. This k is 0 to 3 because the length is 4. 1 into minus 1, 1 into minus 1, 1 into 1. So this will be 0. So the correlation between the code C0 and C1 is 0. This means it is orthogonal. So the codes are orthogonal. This is very important point. So the codes are orthogonal. So these orthogonal codes help us to recover the symbols of the different users from the composite signal. Now this is one of the key properties of the codes employed in CDMA wireless system. Now let's take an example. Let's consider a fundamental property of CDMA system arising because of the employment of these codes. Let the symbol rate for the symbol A naught of the user 0 be 1 kilobit per second. Okay, the time period t per symbol is t is equal to 1 by 1 kilobit per second. So this will become 1 millisecond. Okay, so the corresponding bandwidth is equal to 1 by t, so that is equal to 1 kilohertz. Now c naught, that is equal, sorry, x naught, that is equal to c naught into a naught. This we have already found. Thus for each symbol a naught, one has to transmit 4 chips. So thus to keep the symbol rate constant at 1 kilobit per second, the time of each chip has to be set is equal to 1 by 4 of t. So time of each chip is 1 by 4 of t. So that is equal to 0.25 millisecond. So the bandwidth required for this system is equal to 1 by Tc. So that is 1 by 0.25 millisecond. So that is equal to 4 kilohertz. So this is the spreading of the original signal bandwidth. So this phenomenon is known as spreading of the original signal bandwidth. Okay. So it is also termed as a spreading code, and also uh, it occupies a large bandwidth. So it is termed as a spread spectrum or wideband system. So CDMA termed as a spread spectrum or wideband systems. So here we can see the plot. The original bandwidth was required was 1 kilohertz, but now the complete bandwidth required is 4 kilohertz. So this was the narrow band signal, and this is wide band spread spectrum. So there can be different orthogonal spreading codes which are orthogonal to each other. So now it can parallel transmit the n symbols over n codes in a CDMA. So the multiple access is enabled. Now coming to the spreading code based on pseudo noise sequence. Let me charge my laptop. So now we will study the spreading codes based on pseudo noise sequence. So this PN sequence, pseudo noise sequence are generated using linear feedback shift register. So this PN sequences are generated using linear feedback shift register. So this is known as LFSR. So basically in LFSR, the output is the XOR, like output gives the feedback with some delay D. Let's suppose this is our input Xi. After a delay of 1 unit, the input will become Xi minus 1, then Xi minus 2. Again, we will add a delay unit. It will become Xi minus 3. And the output will be Xi minus 4. So this is our output. Now output will give feedback, and this feedback is in such a way that it is a XOR of Xi minus 3 and Xi minus 4, and this is given to input Xi. Okay, so this is known as linear feedback shift register. So the input Xi is equal to Xi minus 3 XOR of Xi minus 4. So now we will see some formulas that is derived in the class. You can see the lectures in the class. So for D is equal to number of delay registers. The maximal length of code generated is 2 to the power of D minus 1. So for D is equal to 4, for D is equal to 4, maximal length will be 15. Now come to the properties of PN sequences. So the first property is, I will directly write the properties. You can see the derivations in the class. Number of ones is nearly equal to number of minus ones. So this is also known as balanced property. Now coming to the second property, that is run. So this is also known as a string of continuous values. So let's suppose the PN sequences is given as minus 1, minus 1, minus 1, minus 1, 1, 1, 1, minus 1, 1, 1, minus 1, minus 1, 1, minus 1, 1. So this is the sequence of 4 length. L is equal to 4, same sequence. L is equal to 3, L is equal to 1, L is equal to 2, L is equal to 2, L is equal to 1, L is equal to 1, and L is equal to 1. So total run is 1, 2, 3, 4, 5, 6, 7, 8. So there are 4 runs of length 1. So that is equal to 1 by 2 into 8. That is 4. Now runs of length 2 is equal to 2. So that is 1 by 4 into 8, that is equal to 2. Now runs of length 3 is equal to 1 by 8 into 8, that is equal to 1. So out of total runs, total number of runs, 1 by 2 to the power of n of total runs are of length n. Okay, so this is the formula, 1 by 2 to the power of n. So the formula is runs of length n is equal to 1 by 2 to the power of n into total runs. So this is the formula. Now coming to the property 3, and after this we will start solving the questions. So this is the autocorrelation property. So in this 1 by n of Cn code of n minus d shift. So this d is the shift. Cn can be plus minus 1, and n is the length of pseudo noise sequence. So if d is equal to 0, so this 1 by n of summation of Cn, C of n minus d, this will be 1 by n of summation of C of n squared. So this will be 1 by n of n. So this will be 1 because C square of n will be 1. So if d is equal to 0, autocorrelation of Pn sequence is equal to 1. Now if d is equal to now non-zero, so I will directly write the formula, autocorrelation of Pn sequence is equal to 1 by n, and this will be equal to 0 for large value of n. Sorry, here it will be minus 1 by n. So the diagram we can draw as so for any non-zero value, it is becoming 1 by n, that is nearly equal to 0, and for 0 the autocorrelation is 1. So this is the autocorrelation curve of PN sequence. So now coming to the question number 1. So the autocorrelation of the PN sequence of length 63 for non-zero shift is. So for non-zero shift is 1 by n. So the solution will be minus 1 by n. So this will be equal to minus 1 by 63. So option A is the correct answer for this question. So now we'll move on to the second question. Mobility of a user in a wireless network leads to which feature of the wireless channel? So the mobility leads to the time selectivity of the wireless channel. So option B is the correct answer for this question. Moving to the third question. For a flat fading wireless channel, signal bandwidth is lower than coherence bandwidth. So option C is the correct answer, because for a flat fading wireless channel, the signal bandwidth is lower than the coherence bandwidth and signal is reconstructed completely. Now coming to the question number 4. Consider a mobile user moving with a velocity of 60 km per hour, kilo miles per hour at a carrier frequency of 1 gigahertz and an angle of 60 degree. The coherence time of the channel is. So we all know the Doppler shift equation. So this question can be solved using Doppler shift. The formula is Fd is equal to Fc into V cos theta divided by C. So here Fc is carrier frequency, that is given as the Fc carrier frequency is given as 1 gigahertz. Okay, and the theta is 60 degree, the angle between the mobile user and the base station. So theta is the angle so theta is the angle between the mobile user and base station. So this theta is 60 degree. Okay, now c is the speed of light, that is 3 into 10 to the power of 8 meter per second. So all these terms are given in this question. Now we can find directly the Doppler frequency, and this 1 gigahertz is 1 into 10 to the power of 9 hertz. So we substitute all this value and finally we will get, and the velocity of the user is 60 kilometer per hour. So now change the velocity into meter per second. So it will become 60 into 1000 divided by 3600 meter per second. So that will be 100 by 6, that is equal to 50 by 3. It is 50 by 3 meter per second, and cos 60 degree that is 1 by 2, and the speed of light is 3 into 10 to the power of 8. So we will get 10 into 50 divided by 3 into 3 into 2. So our Doppler frequency will become 500 by 18. So it will become 27.78 hertz. So now the coherence bandwidth, the coherence time is 1 by 4 of Doppler frequency. So coherence time Tc is equal to 1 by 4 of Fd. So that is equal to 1 by 4 into 27.78 second. So this will become around 9 millisecond. So from among all these options, option A is the correct answer for this question. Now we will move on to the question number 5. That is, consider the linear feedback shift register LSFR is given, and the state is given xi minus 1, xi minus 2, xi minus 3, and xi minus 4. So the input is xi, like how we have studied. To the linear feedback shift register, the input is xi, and after a delay we will get xi minus 1. Again a delay register is used, xi minus 2. Once again the delay register is used, we get xi minus 3, and the final output is xi minus 4. So this is our output. Okay, now the output also provides the feedback to the input, so that is the XOR value of this xi minus 3 and xi minus 4, and this feedback is given to the input. So the finally our xi is the XOR of xi minus 3 XOR xi minus 4. Okay, so now when we solve this, xi minus 3 is, what is the value? Current state is given. Current state is given as 1101. So this is our input xi, this is our output xi minus 3 4, xi minus 3, xi minus 2, and this is xi minus 1, sorry. So the input will be xi minus 3 XOR xi minus 4, that is 0 XOR 1. So this value is 1. So the next step will be 1110. So the next step is 1110. So our correct answer is option number B. So now we will move on to the question number 6. So it is given, consider a two user downlink CDMA scenario with desired user power P naught is equal to 3 dB. So 10 log 10 of P naught is equal to 3. So P naught will be, log 10 of P naught will be 0.3. So P naught will be 10 to the power of 0.3. So when we do this value, you will get 2. Now P1 is 0 dB. So when you transform log 10 P1 is equal to 0. So P1 is equal to 10 to the power of 0, that is equal to 1. The next is the desired user channel coefficient H is given as 1 plus J, and the noise power is sigma squared. that is given as 2. Our noise power is 2, and the spreading code length n is given here 8. N is equal to 8. So the SINR of the desired user 0 will be. So the formula of signal is to noise and interference ratio SINR is equal to mod of h squared p naught n power of the symbol, and the noise and interference power, that is sigma squared h squared p1. So this extra term here, you can see the channel magnitude into the power of the symbol 1. So this is the interference interference due to symbol transmitted to user 1. So now substitute all the value. So SINR will be 1 plus 1 whole square. P naught is 2. Length is 8. Sigma square is 2. H is again 1 square plus 1 square to the whole square. And P1 is 1. So finally we will get 2 into 2 into 8 divided by 2 plus 2 into 1. So it will be 32 by 4. So that is equal to 8. So SINR in dB will be 10 log 10 of 8. So the final answer will be 9 dB. So from all the given option, the question, option number D is the correct answer for this question. So it is basically asking SINR of desired user. So this is the formula of SINR. Actually, we are not taking normal SNR. Why we are taking SINR? Because there is an interference due to the symbol transmitted to the user 1. Okay. So now moving on to the question number 7th. Consider the code C naught, that is minus 1 1 1 minus 1, and C1 is 1 minus 1 1 minus 1, and the symbol minus 3 comma 3 for user 0 and 1 respectively. So the net transmitted signal is given as, so the net transmitted signal is given as x naught plus x1. So x naught is transmitted signal to user 0. So x naught is equal to a naught into c naught. So that is minus 3, and c naught is minus 1 1 1 minus 1. So this will become 3 minus 3 minus 3 and 3. Okay. Now x1 is equal to transmitted signal to user 1. So x1 is equal to a1 into c1, that is equal to 3 into 1 minus 1 1 minus 1. So 3 minus 3 minus, sorry, plus 3 and minus 3. X is equal to x naught plus x1. So finally we will get 6 minus 6, 0 and 0. So the net transmitted signal is given as 6 minus 6, 0 comma 0. So option B is the correct answer for this question. So now the receiver at user 0 will receive 6 minus 6 0 0 multiplied with the code, that is minus 1 1 1 minus 1. It will receive minus 6 0 0. So that is equal to minus 12. So that is equal to 6, sorry, 4 into minus 3, that is equal to k into x, k into a naught. Similarly, receiver at user 1 will receive 6 minus 6 0 0. Here it is 1 minus 1 1 minus 1 1 minus 1 1 minus 1. So we will get 6 plus 6 plus 0 plus 0, that is equal to 12. That is equal to 4 into 3, that is equal to k into a1. So in this way, the symbol will be received correctly. Now coming to the question number 8. The total number of run in a PN sequence is 256. Runs is equal to 256. The number of runs of length 2 is 1 by 2 to the power 2 into 256, that is equal to 256 divided by 4, that is equal to 64. The correct answer is option number B. We have already studied this formula, that runs of length n is 1 by 2n into total runs. Okay, so we will use same formula. Just I will write again. Runs of length n is equal to total runs divided by 2 to the power of n. Now CDMA is based on the principle of a spread spectrum. Okay, it is spreading the spectrum using the chips. If n is equal to 4, it will spread by 4 times. If it is 8, it will spread by 8 times. Now coming to the question number 10, the transmitted CDMA signal is, for code C0 is given as 1111, C1 is given as 1 minus 1 minus 1 1, and symbol is 2 minus 2 for user 0 comma 1 respectively. The net transmitted signal is, so the net transmitted signal is x is equal to x0 plus x1. So x is equal to a0 c0 plus a1 c1. So x is equal to 2 1 comma 1 comma 1 comma 1 plus minus 2 1 minus 1 minus 1 1. So x will be 2 2 2 2 plus minus 2 plus, here it will be plus 2 and minus 2. So x is equal to 0 4 4 0. So option A is the correct answer for this question. So finally, today we'll close the lecture here only. Thank you for attending, and we will record this lecture, and this lecture will be uploaded on the YouTube, and the link will be shared in the NPTEL portal. If you have any doubt, you can ask now, or you can ask in the comment box. Thank you everyone. We'll close the lecture here. There is no doubt.